Dear students, today we will learn about Wheatstone Bridge. What is Wheatstone Bridge? It is an arrangement of 4 resistors used to determine the value of unknown resistance in terms of others. Now come to construction. What is construction? It consists of 4 resistances P, Q, R and S in the 4 arms of a quadrilateral A, B, C, D. A galvanometer is connected between B and D through a key K2. A source of EMF, that is a cell, is connected between A and C through key K1. So now come to balanced condition of Wheatstone Bridge. So you remember, in the balanced condition, no current flows through the galvanometer, that is Ig is equal to 0. When no current flows through the galvanometer, then you will get P by Q is equal to R by S, that is this resistance divided by this resistance is equal to this resistance divided by this resistance. So now we will prove this balanced condition. We will prove this balanced condition by applying Kirchhoff's law. So now if you close the keys K1 and K2, then the current starts flowing through the circuit. Let I be the current coming from the positive terminal of the cell. Then the same current I will go to the negative terminal of the cell. You see here the current I1 flowing through the resistance P, and I2 is the current flowing through the resistance R. I3 is the current flowing through resistance Q, and Ig is the current flowing through the galvanometer G, and I4 is the current flowing through the resistance S. So now you apply the Kirchhoff's voltage law to the loop ABDA. You consider the loop ABDA. You apply Kirchhoff's voltage law. That is, when you go in this path, that is when you go from A to B, then the voltage drop is I1P. In the same direction, the voltage drop is positive, and the voltage drop is the product of the current and corresponding resistance. Then from this to this, that is same direction of the current is Ig, that is plus Ig, and the resistance of the galvanometer you take, it is Rg. Rg is the resistance of the galvanometer. Then from D to A, you see it is the direction of the current. You are going in the opposite direction of the current, that is the sign is negative, that is minus I2R is equal to 0. In the balanced condition, Ig is equal to 0. That is I1P, when you put Ig is equal to 0 in this equation, you will get I1P minus I2R is equal to 0, or I1P is equal to I2R. Let it be equation number 1. Now you consider this loop BC, D, B, and you apply Kirchhoff's voltage law, KVL, loop rule. When you go from B to C, then it is I3Q, same direction of the current. When you go from C to D, you see it is opposite direction of the current. So it is minus I4S. The resistance here is S. And from D to B, you see you are going in opposite direction to the current IG. That is, the voltage drop is minus Ig into Rg is equal to 0. In the balance condition, Ig is equal to 0. So I3Q minus I4S is equal to 0 since Ig is equal to 0. Or I3Q is equal to I4S. It is your equation number 2. Now dividing equation 1 by equation 2. What will you get? It is your equation 1. So it is I1P divided by I3Q is equal to I2R divided by I4S. It is an equation number 3. Now you apply junction rule. Apply KCL to the junction B. B is the junction. Here you see. Here I1 is the current coming to the junction B. I3 and Ig are the current going away from the junction B. So you can write I1 is equal to I3 plus Ig. But Ig is equal to 0. Therefore I1 is equal to I3. Similarly, you apply Kirchhoff's current law, that is junction rule, to the junction D. You see, I2 is the current going to the junction D, Ig is the current going to the junction D, and I4 is the current going away from the junction D. So you can write I2 plus Ig is equal to I4. For balance condition, Ig is equal to 0. Therefore, I2 is equal to I4. Since Ig is equal to 0. So now, in place of I3 you can write I1, and in place of I4 you can write I2. So from equation 3, you see I1P in place of I3 you can write I1Q is equal to I2R divided by, in place of I4 you can write I2S, or you can get P by Q is equal to R by S. It is the balanced condition of Wheatstone Bridge, hence proved. Here we have proved the balanced condition of Wheatstone Bridge. So one question I will ask here: if you interchange the position of the cell and the galvanometer, then whether the bridge is balanced or not. That means if you will connect the galvanometer in place of cell and cell in place of galvanometer, then the bridge is balanced or not. So let us verify it. In place of galvanometer, you will connect cell and in place of cell, cell is connected between A and C. Between A and C, you connect galvanometer. Now, you see, the bridge is balanced if R by P is equal to S by Q. Previously we have found P by Q is equal to R by S. So from this you can write R by P is equal to P will go to here and S will go to here. That is R by P is equal to S by Q. So you see the bridge is balanced. That means if you interchange the positions of galvanometer and cell, then the Wheatstone bridge still remains balanced. So now come to one question based upon this balanced condition of Wheatstone bridge. You see here P, let it be 5 ohm, 10 ohm, 3 ohm, 6 ohm, it is 15 ohm. My question is to find equivalent resistance between A and B. So you see here whether the bridge is balanced or not. Let it be P, it is Q, it is R, it is S. You see what is P by Q? P by Q, that is 5 by 10. That is 1 by 2. Similarly, R by S, it is 3, it is 6, it is also 1 by 2. That means P by Q is equal to R by S, you see here. That means the bridge is balanced. The bridge is balanced means no current flows through this resistor. So you remember, in an electrical network, if no current flows through a resistor, you will ignore that resistor. So now we will ignore this resistor. So now you can say what is the combination. You see these two resistors are in series and these two resistors are in series. Their equivalents are in parallel. Because if it is connected to the positive terminal, it is connected to the negative terminal, the current I is coming. And here the current splits up, let it be I1, it is I2. You see the same current is flowing through 5 and 10 ohm and the same current flows through 3 and 6 ohm. So these two resistors are in series and these two resistors are in series. Their equivalents are in parallel. So RS1, that is 5 plus 10, that is 15 ohm, and RS2, that is 3 plus 6, that is 9 ohm. Now what is the equivalent resistance? That is these two are in parallel. So 15 into 9 by 15 plus 9. This is the equivalent resistance of the combination. You will solve it. So it is all about your Wheatstone bridge. In the next class, we will discuss very important topic, that is your meter bridge.